Hello viewers, I'm Keerti Bhave. Welcome to the session on electrolysis of aqueous electrolytes using inert electrode. After going through this video, you will be able to write an electrochemical process and reaction of aqueous electrolytes using inert electrodes and predict the products formed in an electrochemical process. Let us revise some facts about electrolysis. Electrolysis of fused electrolytes using inert electrodes yield products at the electrodes. There is only one cation and one anion. Cation discharge at cathode while the anions discharge at the anode. Today, we'll do electrolysis of aqueous sodium chloride using platinum electrodes. Platinum electrodes are inert electrodes, that is, they do not take part in an electrochemical process. Now this is an electrolytic cell. There are electrodes made up of platinum, one connected to the positive terminal of the battery, hence it gets a positive charge. It is the anode. The other connected to the negative terminal of the battery gets a negative charge. It is the cathode. The electrolyte, which is a reactant in an electrochemical reaction, is aqueous NaCl. Aqueous NaCl is sodium chloride dissolved in water. The electrolyte has sodium ions and chloride ions from ionization of sodium chloride. Because it is aqueous, the electrolyte also has hydrogen ions and hydroxyl ions coming from ionization of water. That is, in this electrolyte, you have two cations, the sodium ion and hydrogen ions, and two anions, the chloride ions and hydroxyl ions. Now here, there are two cations and two anions. What do you expect to happen on passage of current? What are the products formed at the electrodes? Let us see what happens at the cathode. There are two cations, sodium ion and hydrogen ions. Both of them move towards the cathode on the passage of current, but only one discharges. Now the question is, which one? To decide as to which one will get discharged, we have an electrochemical series for a reference. An electrochemical series for cations is where all the metal ions are placed in the decreasing order of their stability. That is, the ions which are more stable are placed at the top, and as we go down, the ions become less and less stable. Whenever we have to make a choice as to which of the ions will get discharged, we refer to the activity series or the electrochemical series. The ion which is lower in the electrochemical series gets discharged, while the ion which is higher in the electrochemical series does not get discharged. Thus, of the two cations, sodium ions and hydrogen ions, hydrogen ion gets discharged as it is lower as compared to sodium. That is, The hydrogen ion takes up an electron, becomes hydrogen atom. And because the atomic state of hydrogen is not so stable, two such hydrogen atoms come together to form hydrogen molecule. Thus, hydrogen gas is liberated at the cathode because of the electrolysis of aqueous sodium chloride. Let us see what happens at the anode. Again, there are two anions, the chloride ions and the hydroxyl ions. Both of them move towards the anode, but only one discharges. Which one? Again, for deciding as to which one will get discharged, we have an activity series or an electrochemical series for the anions, where the anions are placed in the decreasing order of their stability. The more stable ion at the top and the least stable ion at the bottom. Like in case of the cations, the ion which is lower in the electrochemical series gets discharged, and the ion which is higher in the electrochemical series does not discharge and remains as such. Here we have two cations, the chloride ions and the hydroxyl ions. Hydroxyl ions get discharged as they are lower in the activity series. The discharge of hydroxyl ions gives oxygen at the anode. This happens when the electrolyte is dilute. It has been observed that if we use concentrated electrolyte, chloride gets discharged and chlorine gas is formed at the anode. Thus, the electrolysis of aqueous sodium chloride, hydrogen is formed at the cathode while oxygen is formed at the anode when the electrolyte is dilute, and chlorine is formed when the electrolyte is concentrated. Let us see how we can write it. This is called as schematic representation of electrolysis of aqueous sodium chloride using inert electrodes. So you have the cathode, you have the anode, then you show the ionization of sodium chloride into sodium ions and chloride ions, the ionization of water into hydrogen ions and hydroxyl ions, the reaction at the cathode giving hydrogen gas, the reaction at the anode giving either oxygen or chlorine depending upon the concentration of the electrolytes. To understand this, let us again see some other electrolyte. Let us take the example of aqueous copper sulfate. So this is electrolysis of aqueous copper sulfate using platinum electrode. This is an electrolytic cell and two electrodes which are basically made up of platinum. One of them connected to the positive terminal, hence it is the anode. The other connected to the negative terminal of the battery and hence it is the cathode. The electrolyte is aqueous copper sulfate, that is, copper sulfate dissolved in water. The electrolyte has copper ions and sulfate ions from ionization of copper sulfate. The electrolyte has hydrogen ions and hydroxyl ions from ionization of water. There are two cations, copper ions and hydrogen ions, and two anions, the sulfate ions and hydroxyl ions. Let us see what happens at the cathode. When current is passed, there are two cations, the copper ions and hydrogen ions. These two move towards the cathode, but we know only one will get discharged. And now we know which one, for which we have to refer to the electrochemical series of cations. In the electrochemical series of cations, we see that the copper ion is lower as compared to the hydrogen ions. The lower ion will get discharged. The higher one remains as such. So, of the two, copper and hydrogen, copper ions get discharged. That is, they will accept electrons and form copper. So, as a result of electrolysis of copper sulfate solution, that is aqueous copper sulfate, copper is formed at the cathode. What happens at the anode? Again, to know what happens at the anode, we have the activity series or the electrochemical series to refer to. There are two anions, sulfate ions and hydroxyl ions. Both of them will move towards the anode when current is passed. But only one will get discharged. Which one? We refer to the electrochemical series. The lower one gets discharged while the upper one remains as such. Thus, of the two cations, sulfate and hydroxyl ions, the hydroxyl ions get discharged and oxygen gas is liberated at the anode. So, because of the electrolysis of aqueous copper sulfate, we have copper at the cathode and oxygen at the anode. Let us see how we can write this equation. It is the schematic presentation of electrolysis of aqueous copper sulfate using inert electrodes. You will show the ionization of copper sulfate giving copper ions and sulfate ions, the ionization of water giving H ions and OH ions. Then, out of copper and hydrogen, copper ions being lower in the activity series will get discharged, forming copper at the cathode. Hydroxyl ions being lower in the electrochemical series of anions get discharged, giving oxygen. As a result of electrolysis of aqueous copper sulfate using inert electrodes, copper is formed at the cathode and oxygen is liberated at the anode. Let us summarize what we did today. More than one cation, if present in an electrolyte, only one cation gets discharged at the cathode, depending on its position in the electrochemical series of cations. The one which is lower gets discharged. And if there are more than one anions in the electrolyte, only one anion will get discharged, depending on its position in the electrochemical series of anions. The one which is lower gets discharged. I hope you have understood the concept and you will be able to rightly predict the formation of compounds at the electrodes. Happy learning. Thank you.